Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we go through theoretical probability. So let's first look at what probability actually is. So probability is the assigning to random events a number between 0 and 1 to indicate how likely they are to occur. So what does all that mean? Firstly, we're talking about random events. So we're only interested in calculating the probability of an event whose outcome is left at least partly due to chance. Like, we're not going to calculate the probability that I wear red tomorrow, because that's not down to chance at all. That's something that I totally control. But what we do is we calculate the probability of events left to chance. Like, if I toss a coin, whether it comes heads or tails is left to chance. If I roll a die, the outcome of the die is left to chance. So we're only interested in those kind of events. Now what we do is we give those events a number to indicate how likely they are to occur. So if the number's close to 1, then the event's very likely to occur, and if it's close to 0, it's more likely that it won't occur. So we can display this on a number line. On your screen is a number line between 0 and 1. So when we're giving these events a number to indicate how likely they are to occur, we always give a number between 0 and 1. So what that means is if I ever say, what's the probability of blah, 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 you have to return with a number between 0 and 1. It doesn't matter whether it's a fraction, decimal, or percentage, but you can't ever have a probability more than 1 or less than 0. So if I say, what's the probability you come to school tomorrow, for example, you can't give me the number 2. An event cannot have a probability of 2. So if an event has a probability equal to 0, that means it's impossible. There is absolutely no way it can occur. And if an event has probability 1, that means it's certain. There's no way it won't occur. Very few things, though, that we go through are impossible or certain. So, of course, halfway between that, an event could have probability of a half or 0.5. You can also write as 50%, doesn't matter. So events with a probability of 0.5, they're 50-50. They're just as likely to happen as to not happen. So if the probability is 0.5, it has an equal chance of happening or not happening. So halfway between 0.5 and 0 is the number 0.25. So if an event has a probability down here in this area, we'd say it's unlikely to occur. It's more likely that it won't occur. So as we get closer and closer to 0, the event is less and less likely. So of course, halfway between 0.5 and 1 is 0.75. So events with a probability up here are likely, and as we get closer and closer to 1, the event is more and more likely to happen. So an example of an event that is impossible is rolling a 7 on a normal 6-sided die. If it's only labelled 1 to 6, there's absolutely no chance you'll roll a 7. So an example of an event that's unlikely to occur is rolling a 1 on a normal 6-sided die. We don't yet know how to calculate its probability. We haven't gone through that. But our intuition tells us it's more likely you will not get a 1 if you roll a die. There's more ways that you can not get a 1. So that's unlikely to occur. So an example of an event whose probability is 0.5 is rolling an even number on a normal 6-sided die. There's a 50-50 chance that you'll roll an even number as you will roll an odd number. So an example of an event that's likely is if you roll a die and you don't get a 1. It's not certain that you won't get a 1, but it's more likely that you will not get a 1 than you will get a 1. So an example of an event that is certain is if you roll a die, you'll get a number less than 7. So that will absolutely happen. There's no chance it won't happen. Note, if I ask you the probability that something happens, you need to respond with a number. So if I say, what's the probability I roll an even number on a normal 6-sided die, you need to give me 0.5 or a half. You don't say equal chance or 50-50. You don't respond with words. These words are just descriptions to help us know what's going on. All right, the next concept we have to cover is sample space. Please pause and copy this down if you need. So the sample space is just a list of possible outcomes of a random event. So when we do an experiment, what are the results that could occur? So if we toss a coin, the possible outcomes are heads or tails. So we can just write HT to denote heads and tails respectively, rather than writing out the full word. Now, because this is actually mathematically a set, we need to use the squiggly brackets. So you need to write the outcomes in the squiggly brackets like that. So if I roll a die, so the list of possible outcomes, so squiggly brackets, I could get a 1, 2, 3, 4, 5, or 6. They are the possible outcomes. If I pick a random letter from A, B, C, D, you guessed it, squiggly brackets, and the possible outcomes are A, B, C, or D. So if I toss 2 coins now, so there are actually 4 outcomes. I could get heads on both. I could get heads the first time, then tails the second time. I could get tails, then heads, or both tails. So all of these 4 red sets enclosed in the squiggly brackets, they constitute the sample space of their respective experiments. It's important that we can list the outcomes in the sample space because that's going to help us determine the probabilities. We need to know how many possibilities there are in order to calculate probabilities. So the way we actually calculate the probability of an event is using this formula up here. So it says the probability of an event, which is PE, is equal to the number of ways it can occur. The number of ways the event can occur is NE, divided by the total number of outcomes. So this here, NS, means number of events in the sample space. That's how many total possibilities there are. So let's say I toss a coin. If I write this here, PH, that means the probability I get heads. So there's one way I can get heads over 2 possible outcomes. So the probability of heads is a half. We probably already knew that. So let's go to the second one, and let's say I roll a die. So I'm going to calculate the probability that the number I roll is a multiple of 3. So I'm going to use this formula up here. So to find the probability, I first need to calculate the number of ways it can occur. So the number of ways I can get a multiple of 3, I can get a 3 or a 6. There are 2 ways it can occur. And the total number of outcomes, the number of events in the sample space, we can see that there are 6 such outcomes. So the probability is 2 over 6. And of course, 2 over 6 simplifies to 1 over 3. And you can also write it as a decimal 0.3 recurring if you like. So that's the probability I roll a multiple of 3. So let's say I'm picking a random letter from A, B, C, or D. I'm going to calculate the probability that I do not get a D. So again, I use this formula up here. It's the number of ways it can occur over the total number of outcomes. So there are 3 ways I can get a letter that's not a D. I can get an A, B, or C. There are 4 outcomes in total. So the probability is 3 over 4. It's also 0.75 if you want to write it as a decimal, that's fine too. Let's look at the last example of tossing 2 coins. So if I toss 2 coins, what's the probability I get at least 1 head? So once again, I'm going to use my formula. The probability of an event is the number of ways it can occur over the total number of outcomes. So how many ways can I get at least 1 head? Well, this one here is at least 1 head. It's 2 heads. This has at least 1 heads. This one has at least 1 heads. This one does not. So there are 1, 2, 3 ways it can occur. So the probability is going to be 3 over, there are 4 events in the sample space. 1, 2, 3, 4. So the required probability is again 3 over 4 or 0.75. So notice each time I calculate the probability of something, the answer I got was a number between 0 and 1. All the time. I gave a number between 0 and 1. I didn't say unlikely or likely. The probability I calculated was never 2 or minus 1 or whatever. So now we're just going to look at a bit more about what theoretical probability means by looking at expectation. So we can view what we've just calculated as the fractional proportion of times that something should happen. So for example, we calculated if we toss a coin, the probability of getting heads is 1 over 2, a half. So that means that we expect that if we toss a coin heaps of times, we'll get heads half of the time. So this is why it's called theoretical probability. When we calculated probability of heads is a half, that was actually the theoretical probability, because it's what should happen. We should get heads half the time and tails half the time. But in reality, we won't necessarily get that. If you toss a coin 10 times, you might not get 5 heads and 5 tails. You might not get heads half the time. What actually happens is experimental probability, and that's what we'll do in the next lesson. But for now, the probabilities we're calculating are the fraction or proportion of times we expect something to happen. So that was the fraction of times we expect something to happen. The number of times we expect something to happen is just the probability multiplied by the number of times we perform the experiment. So I hope you're not feeling a little worried given all the words here, because this is just common sense. For example, if we toss a coin 10 times, the number of times we expect heads is half of 10. Of means times, so it's just half times 10, which is 5. If we toss a coin 10 times, we expect 5 heads. If we roll a die 300 times, the number of times we expect to roll a 6, well, the probability of rolling a 6 anytime we roll a die is 1 over 6. There's 1 6 on the die. There are 6 outcomes in total. So if we roll a die 300 times, we expect to roll a 6 1/6 of the time. So 1/6 of 300, of means times, so that's 50. If we roll a die 300 times, we expect to get 51s, 52s, and so on. We expect 56s. So that's all we mean here by expectation. And that's really at the heart of what theoretical probability is. It is just the proportion of times we expect something to happen. All right, thank you so much for tuning into this video. The first 5 people from my class to mention the word lollipop in this video, you can have one. This has been the luckiest maths teacher in the world. Have a great day.